Picture yourself standing before the Great Pyramid of Giza, listening to your guide confidently explain how ancient Egyptians built this colossal monument using copper chisels and unlimited determination. The story sounds authoritative, but something feels wrong, and you're not alone in that feeling. Across the world, millions of people find themselves questioning the orthodox explanation for humanity's most impressive ancient monument. Tonight, let's begin peeling back the layers of what schoolbooks have long presented as unquestionable history and see why so many continue to doubt and resist the official story of the Great Pyramid. In 1837, Colonel Howard Vyse was having what you might call a very expensive midlife crisis. He's already blown through a fortune using gunpowder to blast his way into various Egyptian monuments, much to the horror of anyone who cares about preservation. After months of explosive archaeology yielding nothing but rubble and criticism, Vyse is running out of time, money, and most importantly, credibility. Picture the scene: a desperate Victorian gentleman in a pith helmet, standing before the Great Pyramid with a crew of workers and enough explosives to level a small town. The pressure is mounting. His reputation hangs in the balance. He needs a discovery, and he needs it now. Then, almost miraculously, his workmen make a breakthrough. In a previously sealed chamber, high within the pyramid's core, they discover something extraordinary: red-painted hieroglyphs bearing the cartouche of Pharaoh Khufu. Suddenly, the entire mystery of who owned the Great Pyramid was solved. Case closed, history books written, Nobel Prizes distributed if they'd existed back then. But here's the thing that might keep you awake tonight. This single discovery, made under rather convenient circumstances by a man desperate for validation, has become the cornerstone of everything we believe about the Great Pyramid. Every textbook, every documentary, every confident tour guide pointing at those ancient stone bases their certainty on Colonel Vyse's dramatic find. And that's where our story of reasonable doubt begins. The hieroglyphs themselves tell an interesting story, though perhaps not the one orthodox archaeology would prefer. Unlike every other royal inscription found in Egyptian monuments, these weren't carefully carved into the stone with the reverence befitting a divine pharaoh. Instead, they appear to have been hastily painted with red ochre, the ancient equivalent of spray paint. Imagine discovering graffiti under a highway overpass that says Napoleon was here, and using it to date the entire road system. Modern analysis of these markings has raised some uncomfortable questions. The paint appears to have been applied in a hurry, with several spelling errors that would have horrified any self-respecting ancient Egyptian scribe. One cartouche even misspells Khufu's name. It's the kind of mistake you'd expect from someone copying hieroglyphs from a book, not from royal scribes documenting their god-king's eternal resting place. These inscriptions show no signs of aging, fading, or accumulation of dust and grime you'd expect from 4,500-year-old artwork. They look remarkably fresh for something that predates the Roman Empire by 2 millennia. Dr. Scott Crichton, who has extensively studied these markings, noted something peculiar. The hieroglyphs appear to have been painted over existing quarry marks on the stones, suggesting they were added after the blocks were already in place. This is roughly equivalent to finding someone's signature painted over the manufacturer's label on a car engine and concluding that person built the entire vehicle. None of this proves the inscriptions are forgeries, of course, but it does raise the rather obvious question of why the builder of one of humanity's greatest monuments hangs on evidence that would barely hold up in a small claims court. When pressed on this point, orthodox Egyptologists tend to shift uncomfortably. If the painted hieroglyphs seem a bit shaky as evidence, don't worry. They have a backup plan and call it contextual dating, and it works like this. We know the Great Pyramid was built during the 4th dynasty because it sits near other pyramids that were built during the 4th dynasty. Suggest that perhaps the Great Pyramid might predate the others, and you'll find yourself on the receiving end of academic scorn typically reserved for people who believe the Earth is flat. The contextual dating has become so entrenched that questioning it feels almost heretical, which is usually a warning sign in any field that claims to value evidence-based inquiry. But the real problem with contextual dating isn't just its logical flaws, it's how it prevents us from considering alternative possibilities. If the Great Pyramid were actually much older than the Fourth Dynasty, then what we're seeing at Giza isn't a single massive construction project, but potentially a combination of ancient monuments and later additions. The newer pyramids might have been built around an existing structure, creating the appearance of contemporaneous construction when the reality could be far more complex. This isn't wild speculation. It's exactly what we see in countless other archaeological sites around the world, where later civilizations built upon, modified, or claimed credit for earlier monuments. But at Giza, this possibility is dismissed almost automatically, not because the evidence rules it out, but because it doesn't fit the established narrative. In 1984, a team led by Mark Lehner collected organic materials from the pyramid's mortar and subjected them to carbon-14 analysis. The results seemed to vindicate the orthodox position, showing dates clustering around 2500 BC, right in line with Khufu's supposed reign. Case closed, right? Well, not quite. The problem with carbon dating the Great Pyramid isn't the technology itself, it's what we're actually dating. Radiocarbon analysis can only work on organic materials: wood, charcoal, plant fibers, and bone. It cannot date the massive limestone and granite blocks that form the pyramid structure. What the 1984 study actually dated were tiny fragments of organic material found in the mortar between some stones. This creates a rather obvious problem. Mortar might tell us about repairs and maintenance, not original construction. Every ancient monument undergoes centuries of restoration work, replacement of damaged sections, and addition of new elements. Dating mortar samples is a bit like carbon dating the cork around your bathroom tiles and concluding that your entire house was built last Tuesday. The sample sizes in the 1984 study were also troublingly small, often just a few grams of material collected from scattered locations throughout the massive structure. Drawing conclusions about the pyramid's construction date from such limited samples is roughly equivalent to determining a forest's age by carbon dating a handful of fallen leaves. Even if those leaves are genuinely old, they tell us almost nothing about when the trees were planted. More problematic still is the issue of contamination. Over thousands of years, the pyramid has been exposed to countless sources of newer organic material, plant growth, insect activity, human presence, and extensive restoration work. Each of these can introduce younger carbon into the sample, skewing the dates toward more recent periods. It's notoriously difficult to isolate truly original organic material from such an extensively contaminated environment. Perhaps most tellingly, the 1984 study found significant variations in dates from different areas of the pyramid, with some samples yielding ages several centuries apart. Rather than suggesting multiple construction phases or complex dating issues, these discrepancies were largely dismissed as noise in the data. This is a bit like finding different serial numbers on car parts and deciding they're all typos, rather than evidence that the vehicle was assembled from components made at different times. When independent researchers have attempted to replicate or expand upon the 1984 carbon dating, they've encountered something interesting: access restrictions. Getting permission to extract new samples for dating has proven remarkably difficult, with Egyptian authorities citing concerns about damaging the monument. While preservation is certainly important, it's curious that such restrictions apply most stringently to research that might challenge established timelines. Just when you think the dating problem couldn't get more interesting, Along come the Dixon relics to completely upset the apple cart. This is where our story takes a turn from merely suspicious to genuinely mind-bending. In 1872, British engineer Wayneman Dixon and his friend Dr. James Grant were poking around the Queen's chamber of the Great Pyramid when they noticed something odd. Unlike the King's chamber, which has obvious air shafts leading to the outside, the Queen's chamber appeared to have no ventilation at all. But Dixon suspected that wasn't quite right. Following some barely perceptible air currents and suspicious-looking cracks in the walls, he decided to grab some tools and start chiseling. What Dixon found changed everything, though it would take nearly 150 years for anyone to fully appreciate the implications. Hidden behind the chamber walls were two narrow shafts, and inside the northern shaft, Dixon discovered three curious objects: a small granite ball, a bronze hook, and a piece of cedar wood fashioned into what appeared to be a measuring rod. Two of these objects, the hook and the ball, eventually made their way to the British Museum, where they sat in relative obscurity for more than a century. The wooden piece, however, took a more circuitous route. It remained in Dr. Grant's personal collection until his daughter donated it to the University of Aberdeen in 1946. Then, in the way that academic institutions sometimes misplace things, it disappeared into storage and was promptly forgotten. Fast forward to 2020, when curatorial assistant Abir Eladani was sorting through old collections and stumbled upon a dusty cigar box labelled with Egypt's old flag. Inside, wrapped in newspaper, was a small piece of cedar wood that would soon rewrite everything we thought we knew about the pyramid's age. The wood was sent for radiocarbon dating, and the results were nothing short of explosive. Instead of dating to around 2500 BC, during Khufu's supposed reign, the cedar fragment returned dates of 3341 to 3094 BC, placing it some 500 to 800 years older than mainstream archaeology claims the pyramid could possibly be. Now, orthodox Egyptologists have scrambled to explain this inconvenient finding. The most common argument is that cedar wood can live for hundreds or even thousands of years, so perhaps this piece came from the heartwood of a very ancient tree that was already centuries old when it was used in the pyramid's construction. Yet another fascinating hypothesis takes shape when someone discovers evidence that completely upends their conclusion. If the Dixon relics truly date the pyramid's construction to the 4th millennium BC, then the Great Pyramid predates not just Khufu, but the entire 4th dynasty. It predates the supposed invention of writing in Egypt. It predates the unification of Upper and Lower Egypt under the first pharaohs. In fact, it pushes the pyramid's construction back into what archaeology considers prehistoric Egypt, a time when the region was supposedly populated by simple farming communities with no knowledge of monumental architecture. Perhaps the most telling aspect of the Dixon relics discovery isn't the carbon dating itself, but the response from the archaeological establishment. You might expect such a significant finding to generate intense research interest, heated academic debates, and immediate calls for additional testing and verification. Instead, the response has been remarkably muted. It's been largely ignored, dismissed, with hand-waving about old wood, or simply not discussed in most academic circles. But perhaps most frustrating is that we could easily resolve these questions with additional testing. There's still a wooden rod inside the pyramid shaft, clearly visible in footage from robotic explorations, that could provide additional dating material. Yet access to conduct such research is routinely denied. Standing at the end of our exploration into the pyramid's dating, we're left with a picture that looks nothing like the confident certainty presented in textbooks and documentaries. The foundation of everything we believe about when the Great Pyramid was built rests on Victorian graffiti of questionable authenticity carbon dating of repair materials rather than original construction, and institutional resistance to the evidence that challenges timelines. The pattern here isn't scientific inquiry, it's intellectual protectionism. When evidence supports the orthodox narrative, it's embraced and extensively studied. When it raises uncomfortable questions, it's dismissed, explained away, or simply ignored. This isn't how science is supposed to work, and it certainly isn't how we should approach one of humanity's greatest monuments. But even if you accept the textbook claim that the Great Pyramid was indeed built by Pharaoh Khufu around 2580 BC, the moment you gaze up at this colossal monument, you're confronted with an unavoidable question. What extraordinary methods could possibly have created it? How exactly did a Bronze Age society accomplish feats of engineering that modern machinery still struggles to replicate? Starting with some basic numbers, because sometimes the simplest mathematics can be the most devastating to comfortable assumptions. The Great Pyramid contains approximately 2.3 million stone blocks with an average weight of about 2.5 tons each. But averages can be misleading. While many blocks are indeed in that 2 to 3 ton range, others are substantially larger. The granite blocks in the King's Chamber weigh between 25 and 80 tons each, and some of the limestone blocks in the lower courses tip the scales at over 15 tons. If we accept Orthodox archaeology's claim that the pyramid was built in 20 years, we can do some simple division. 2.3 million blocks divided by 20 years equals 115,000 blocks per year. Divide that by 365 days and you get roughly 315 blocks that would need to be quarried, transported, lifted, and precisely positioned every single day for 2 decades. That's more than one block every 5 minutes, assuming work continued 24 hours a day, 7 days a week, with no breaks for holidays, no days lost to weather, no time off for workers, and absolutely no mistakes requiring rework. But even these daunting numbers don't capture the full scope of the challenge, because not all blocks are created equal. Moving a 2-ton limestone block is difficult enough with Bronze Age technology, but it's theoretically possible with enough people and proper technique. Moving an 80-ton granite block is an entirely different category of impossibility. To put this in perspective, modern construction projects consider anything over 50 tons to be a heavy lift, requiring specialized equipment and extensive planning. The largest crane-lifted objects in today's construction rarely exceed 100 tons, and those operations require months of preparation, computer modeling, and equipment that costs millions of dollars. Yet we're asked to believe that ancient Egyptians routinely handled 80-ton blocks as part of their daily construction routine. The logistics become even more mind-bending when we consider transportation. Some of the granite used in the pyramid's internal chambers was quarried at Aswan, more than 500 miles south of Giza. That means these massive blocks had to be extracted from solid bedrock, loaded onto boats, transported hundreds of miles down the Nile, unloaded at Giza, moved to the construction site, and then lifted hundreds of feet into the air to their final positions. Each step of this process would have been extraordinarily difficult with ancient technology. Extracting 80-ton blocks from solid granite quarries without explosives or power tools would have taken months per block. Loading them onto wooden barges without cranes would have required engineering solutions that no ancient civilization is known to have possessed. Transporting them hundreds of miles without modern navigation or weather forecasting would have been a feat worthy of its own monuments. In 1978, a team of Japanese researchers decided to settle the question once and for all by building their own pyramid using authentic ancient techniques. They planned a modest 20-meter tall pyramid, a fraction of the Great Pyramid's 146-meter height, and recruited 100 Egyptian workers to provide traditional construction knowledge. With modern organizational skills, unlimited budgets, And the benefit of knowing exactly what they were trying to achieve, the project should have been straightforward. It was anything but. The first problem emerged immediately. Cutting stone blocks using copper chisels and stone hammers proved so time-consuming and inefficient that the project timeline became absurd. After days of continuous work, teams of skilled workers could barely produce a single block of acceptable quality. At this rate, building even their modest pyramid would have taken several decades rather than the planned few months. Faced with this reality, the Japanese team made their first compromise. They reduced the target height from 20 meters to 10 meters, cutting the required stone blocks by roughly 75%. Even with this dramatic reduction in scope, the stone cutting phase continued to fall impossibly behind schedule. Eventually, the team abandoned authentic techniques altogether and began using power saws to cut their blocks. So much for proving ancient methods were viable. The transportation phase proved equally problematic. Ancient Egyptian boats, reconstructed using traditional techniques and materials, simply couldn't handle the weight of stone blocks without structural failure. The team had to resort to modern cargo vessels to move their materials. Even with modern boats, loading and unloading the blocks required contemporary cranes and heavy equipment. The final phase, actually assembling the pyramid, required abandoning any pretense of authentic construction methods. Despite having blocks that were 1/4 the weight planned for 1/20th the height, the team needed modern cranes to lift blocks into position. When even this proved insufficient for the upper levels, they brought in a helicopter to complete construction. The Japanese experiment, intended to vindicate orthodox theories about ancient construction methods, instead demonstrated their complete impossibility. A team with modern organization and the benefit of contemporary engineering knowledge couldn't build even a tiny pyramid using supposedly ancient techniques. Yet we're asked to believe that Bronze Age Egyptians built a structure 50 times larger using methods that defeated modern experts. The scale and transportation challenges, daunting as they are, pale in comparison to the precision problem. It's one thing to move massive blocks, it's another thing entirely to place them with the kind of accuracy displayed throughout the Great Pyramid. The precision of construction isn't just impressive, it's impossible to explain. Start with the foundation, which spans more than 13 acres and is leveled to within less than an inch. This kind of precision requires not just careful construction, but sophisticated surveying techniques to ensure accuracy over such a vast area. Modern construction achieves this kind of flatness using laser leveling systems and computer-controlled grading equipment. How Bronze Age Egyptians accomplished the same result using string lines and wooden stakes remains a complete mystery. The blocks themselves display precision that would challenge modern stoneworkers. The joints between blocks are so tight that you literally cannot insert a razor blade between them. The blocks weren't just cut to approximate size and forced into place, they were shaped to tolerances that would impress contemporary machinists. Even more remarkably, this precision extends throughout the entire structure. Virtually every stone in the pyramid fits with the same extraordinary precision. The consistency of this accuracy suggests manufacturing processes rather than hand craftsmanship. The granite blocks in the internal chambers present their own precision puzzles. Granite is one of the hardest stones on Earth, containing quartz crystals that can shatter steel tools. Working granite to precise tolerances requires diamond-tipped cutting tools and carbide steel machinery. Yet the granite blocks in the king's chamber display finish quality that rivals modern machine work. Christopher Dunn, a precision machinist who has extensively studied the pyramid stonework, discovered evidence of techniques that shouldn't have existed in the ancient world. Core samples from granite blocks show spiral striations consistent with high-speed rotary drilling, the kind of marks left by diamond core drill bits spinning at thousands of revolutions per minute. These aren't the rough, irregular holes you'd expect from copper chisels and stone hammers. They're perfectly round holes with smooth walls and consistent diameters. Even more puzzling are the saw marks found on various blocks throughout the pyramid. Some blocks show evidence of cuts made with blades that must have been at least 9 feet long, cutting through solid granite in single passes. The kerf marks, the grooves left by the cutting blades, are too narrow and too straight to have been made by copper saws, even if such massive copper blades could have been manufactured and kept sharp enough to cut granite. Mainstream archaeology's standard explanation for the pyramid's precision stonework relies heavily on copper chisels and stone hammers. According to this theory, ancient Egyptian workers painstakingly shaped each block using these simple tools, achieving impossible precision through patience and skill. It's a romantic notion that appeals to our admiration for ancient craftsmanship, but it fails spectacularly when subjected to practical testing. Copper, while useful for many ancient applications, is simply too soft to effectively cut granite. When a copper chisel strikes granite, the copper deforms rather than the stone. Modern experiments with authentic copper tools have consistently demonstrated that while these implements can slowly chip away at limestone, they're virtually useless against harder stones like granite. Dr. Dennis Stocks, an experimental archaeologist who has spent years testing ancient stone-cutting techniques, found that copper chisels could cut limestone at a rate of about 4 millimeters per hour under ideal conditions. This means that cutting a single granite block to the dimensions found in the king's chamber would have required hundreds of hours of continuous work, and that's assuming the chisels could cut granite at all. The tool degradation problem makes these numbers even more optimistic than they appear. Copper chisels become dull and deformed after only a few dozen strikes against hard stone. Each chisel would need to be removed, reforged, sharpened, and returned to work multiple times during the cutting of a single block. The constant tool replacement would have slowed progress to an absolute crawl and required a massive infrastructure for tool manufacturing and maintenance. Even if we assume that ancient Egyptians had unlimited patience and unlimited copper chisels, the precision problem remains unsolved. Hand tools, no matter how skillfully used, cannot achieve the kind of dimensional accuracy displayed in the pyramid stonework. The human eye cannot detect variations of fractions of millimeters, and the human hand cannot control cutting tools to such fine tolerances. It requires measuring and cutting techniques that were supposedly unknown for thousands of years after the pyramid's construction. The soot problem presents yet another challenge to orthodox explanations. Working inside the pyramid's chambers and passages would have required artificial lighting, yet examination of the interior surfaces shows no trace of soot, smoke stains, or other evidence of torch or oil lamp use. The walls and ceilings are remarkably clean, showing no signs of the carbon residue that would inevitably accumulate from flame-based lighting systems. This absence of soot evidence suggests either that the pyramid builders had access to non-flame lighting systems, or that the interior work was accomplished using techniques that didn't require continuous artificial illumination. Neither possibility fits well with Bronze Age technology and construction methods. Some archaeologists have suggested that ancient workers used polished bronze mirrors to reflect sunlight into the interior passages, eliminating the need for flame-based lighting. While ingenious, this explanation fails to account for the complex geometry of the pyramid's internal structure, which would make mirror-based lighting systems extremely difficult to implement and maintain. The impossibilities pile up so quickly that they eventually point toward an uncomfortable conclusion. The Great Pyramid displays evidence of engineering capabilities that Bronze Age Egypt simply could not have possessed. Rather than representing the pinnacle of ancient achievement using primitive tools, the pyramid appears to be the product of sophisticated technology that mainstream archaeology refuses to acknowledge. Recent electromagnetic surveys have detected unusual electrical properties within the pyramid structure. The combination of limestone, an electrical insulator, and granite, a conductor, creates what appears to be a sophisticated electrical system. While we don't fully understand the purpose of this electrical engineering, its existence provides one line of evidence for advanced engineering. As evidence for advanced engineering capabilities continues to accumulate, the response from orthodox archaeology has become increasingly defensive. Rather than embracing new discoveries that might expand our understanding of ancient capabilities, the establishment has doubled down on explanations that become more implausible with each new finding. Research that might reveal the true engineering capabilities of the pyramid's builders is systematically blocked, ensuring that uncomfortable discoveries remain hidden from public view. The pattern of suppression extends beyond just the Great Pyramid to other Egyptian monuments that display similar engineering anomalies. Sites that might provide comparative evidence for advanced ancient technology are placed off-limits to independent researchers while archaeologists continue to publish papers explaining how everything was accomplished with copper chisels and unlimited patience. But perhaps the most telling evidence for the cover-up is the complete absence of failed attempts or practice runs in the archaeological record. If Bronze Age Egyptians really developed pyramid-building capabilities from scratch, we should find evidence of their learning process. Smaller pyramids with obvious mistakes, experimental techniques that didn't work, construction failures that were abandoned and rebuilt. Instead, we find the Great Pyramid standing alone, perfect on the first attempt, displaying engineering capabilities that supposedly took thousands of years to develop but left no evidence of that development process. It's as if the builders appeared out of nowhere with fully formed advanced capabilities, built their masterpiece, and then vanished, leaving behind only the mystery of how they accomplished the impossible. This absence of a development timeline isn't just suspicious, it's the smoking gun that proves orthodox chronology might be fundamentally wrong. Advanced engineering capabilities don't appear overnight. They require generations of experimentation, refinement, and accumulated knowledge. The fact that we see no evidence of this development process suggests that the pyramid's builders inherited their capabilities from an even earlier source. Through the problems in dating and the apparent impossibilities of the construction techniques, you've probably begun to suspect that the Great Pyramid might not have been built by the ancient Egyptians after all. The idea that they inherited it from a forgotten past, civilization starts to sound far more plausible. And history is full of examples where later generations or entire civilizations claimed credit for the achievements of their predecessors. For example, Rome perfected history's most successful rebranding operation, systematically taking Greek products, slapping on "Made in Rome" labels, and distributing them throughout their empire as Roman innovations. The strategy was so effective that modern education still teaches Roman achievements that were actually Greek creations. Picture the process like an ancient corporate takeover. The Romans discovered sophisticated Greek civilization with its temples, sculptures, philosophy, mythology, and engineering. Rather than acknowledging Greek origins, they launched a massive rebranding campaign that transformed borrowed achievements into Roman innovations through strategic marketing and imperial distribution. Greek temples became Roman architecture. Never mind that Romans copied every column, proportion, and decorative element. They added a few modifications and claimed the entire architectural tradition as their own invention. Greek gods became Roman mythology. Jupiter replaced Zeus, Venus replaced Aphrodite, but the stories, relationships, and attributes remained identical. Romans simply changed the names and claimed ownership of entire mythological systems they'd inherited. Egypt itself provides a direct parallel to pyramid mysteries through a well-documented phenomenon that Egyptologists call usurpation. It was so common in ancient Egypt that it's recognized as standard pharaonic practice, rather than exceptional behavior. Successive rulers routinely appropriated tombs, statues, temples, and monuments built by predecessors through the simple expedient of carving new cartouches over the original ones. The oval-shaped cartouche containing the pharaoh's name was the primary identifier of royal ownership, so changing cartouches effectively transferred credit for entire monuments. The process was remarkably efficient. Rather than building new monuments from scratch, an expensive, time-consuming process, ambitious pharaohs could claim credit for existing achievements through recarving campaigns. Rameses II offers the perfect case study, known as Rameses the Great, partly through genuine achievements but largely through systematic appropriation of predecessors' accomplishments. Throughout Egypt, structures begun by his father Seti I and earlier rulers received Rameses II cartouches, transforming inherited projects into personal achievements through simple inscription additions. Abu Simbel demonstrates the process clearly. While Rameses II certainly completed and expanded the temples, historical records show Seti I initiated the project and established its basic design. But Rameses's cartouches dominate the site, and modern archaeological narratives present Abu Simbel as his personal creation, rather than the completion of inherited work. The appropriation succeeded because institutions accepted surface evidence, the inscriptions, without investigating construction sequences that might reveal inheritance rather than innovation. Throughout his reign, Rameses II added inscriptions to monuments built by predecessors, gradually transforming Egypt's architectural landscape into testimony to his supposed building prowess. Later historians, lacking detailed construction records and trained by institutions to accept inscriptional evidence at face value, naturally attributed monuments bearing his cartouches to his building programs. The process explains how entire monument complexes could shift attribution over time. Original builder's evidence gets buried under later additions. Restoration work gets interpreted as original construction. Inscription evidence from appropriators receives more weight than architectural analysis, revealing inheritance. This recurring pattern of stealing the past raises a bigger question. Is the story we've been told about the builders of the Great Pyramid genuine history, or is it merely the starting point of a long tradition of usurpation? If up to this point you still believe the ancient Egyptians truly had everything it took to build the Great Pyramid, then the hidden mathematical codes within the structure will push that belief to its limits, revealing a level of knowledge about geometry, astronomy, and the cosmos that seems far beyond their time. Let's start with pi, the ratio that describes the relationship between a circle's circumference and its diameter. While ancient civilizations used rough approximations for circular calculations, the precise value of pi wasn't calculated to significant accuracy until the work of Archimedes in the 3rd century BC, more than 2,000 years after the pyramid's supposed construction. Yet pi appears to be encoded directly in the Great Pyramid's proportions. If you take the pyramid's perimeter at its base and divide it by twice its height, you get a number remarkably close to pi. The relationship is so precise that it can't be coincidental. The builders would have needed to know pi's value to at least 3 decimal places to achieve this level of accuracy. But pi is just the beginning. The pyramid also encodes the golden ratio, known mathematically as phi, with equal precision. The golden ratio is a special number approximately equal to 1.618 that appears throughout nature, in flower petals, seashells, galaxy spirals, and human proportions. In the Great Pyramid, if you take the surface area of any triangular face and divide it by the surface area of the base, you get pi to several decimal places. Again, this level of precision can't be accidental. The builders would have needed to understand not just the golden ratio's existence, but its exact mathematical value and how to incorporate it into three-dimensional construction. Perhaps most mysteriously, the pyramid's coordinates appear to encode the speed of light. The monument sits at 29.9792458 degrees north latitude, a number that matches the speed of light in meters per second, exactly 299,792,458 meters per second. This could be the most extraordinary coincidence in mathematical history, or evidence that the pyramid's builders possessed knowledge of physical constants that weren't discovered until the development of modern physics. If you place the Great Pyramid next to the Earth, it functions as a precise scale model of the Northern Hemisphere at a ratio of 1 to 43,200. This means that if you could scale up the pyramid by exactly 43,200 times, you'd get a perfect replica of the northern half of the planet. The scale relationship appears in multiple ways throughout the pyramid's design. The base perimeter, when multiplied by 43,200, equals the Earth's circumference at the equator to within a few hundred feet. Extraordinary accuracy considering that the Earth's circumference wasn't accurately measured until the 18th century. The pyramid's height, similarly scaled, matches the distance from the center of the Earth to the poles with comparable precision. Even the specific number 43,200 appears to be deliberately chosen rather than coincidentally derived. This number represents exactly half the number of years in the precession cycle, the slow wobble of Earth's axis that causes the positions of stars to shift over time. It also equals the number of seconds in half a day from sunrise to sunset. The repeated appearance of this number in various pyramid measurements suggests that the builders understood not just Earth's physical dimensions, but its astronomical relationships and temporal cycles. Now consider the orientation of the pyramid. You might think that aligning a building with the cardinal directions is straightforward, but you'd be wrong. It's actually an extraordinarily complex challenge that requires sophisticated understanding of astronomy, precise measurement techniques, and mathematical calculations that ancient Egypt supposedly hadn't developed. The Great Pyramid is aligned to true north with an accuracy that defies belief. We're not talking about a rough approximation or a close enough orientation. The structure deviates from perfect alignment by just 3 minutes and 6 seconds of arc. That's 0.052 degrees, or roughly 1/20th of a single degree. To put this in perspective, if you drew a line from the pyramid's center to the North Pole and another line along the pyramid's northern face, those lines would converge somewhere near the Arctic Circle. The precision is so extraordinary that we couldn't measure it accurately until the development of modern satellite navigation systems. Even with modern equipment, achieving this level of alignment is challenging. The builders of the Paris Observatory, constructed in the 17th century with the finest instruments available to European science, managed to align their building to within 6 minutes of arc, twice the error of the Great Pyramid. Modern construction projects, armed with GPS technology and laser surveying equipment, routinely achieve accuracies measured in minutes of arc, but the pyramid's precision still ranks among the most accurate alignments ever achieved by human construction. Besides, hidden within its structure is an 8-sided design that becomes visible only during specific astronomical events. When viewed from above at sunrise or sunset on the spring and autumn equinoxes, shadows reveal that each of the pyramid's 4 faces is actually composed of 2 slightly angled planes, creating 8 distinct surfaces instead of 4. This phenomenon was first documented in modern times by British Royal Air Force pilot Percy Groves in 1940, though it was likely known to ancient observers. The effect is so subtle that it's invisible under normal lighting conditions and can only be seen when the sun's angle creates precisely the right shadow patterns. Creating this effect requires that each face be built with a slight concave curve, invisible to the naked eye but mathematically precise enough to create the shadow effect only during equinoxes. This level of astronomical and geometric sophistication suggests builders who understood not just basic construction techniques, but advanced relationships between solar positions, seasonal cycles, and three-dimensional geometry. The sophistication of their supposed astronomical knowledge becomes even harder to dismiss once we look at the striking alignment between the Giza Pyramid complex and the constellation of Orion. Robert Bauval first documented this relationship in his groundbreaking work on the Orion correlation theory. The three main pyramids at Giza, the Great Pyramid, the Pyramid of Khafra, and the Pyramid of Menkaure, mirror the arrangement of the three stars in Orion's belt with remarkable precision. The sizes, relative positions, and angular relationships of the pyramids match the stellar pattern exactly. But here's where the correlation becomes truly extraordinary. The pyramids don't match Orion's belt as it appeared during the supposed construction period around 2500 BC. Instead, they perfectly mirror the constellation's configuration as it appeared around 10,500 BC, nearly 8,000 years earlier. This dating correspondence emerges from the phenomenon of precession, the slow rotation of Earth's axis that causes star positions to shift over time. The southern shaft leading from the king's chamber points with laser-like precision toward the position where the central star of Orion's belt would have appeared in 10,500 BC. The northern shaft from the king's chamber aligns with similar precision to the ancient pole star, not the current pole star, but the star that held that position in 10,500 BC. This astronomical precision extends beyond individual alignments to encompass the entire Giza complex. When mapped against the ancient sky, the pyramids, the Sphinx, and associated structures create a terrestrial reflection of significant celestial configurations from 10,500 BC. The entire complex functions as an enormous astronomical instrument encoding star positions and celestial relationships. As the mathematical evidence accumulates, it becomes increasingly difficult to dismiss these relationships as coincidental. The precision is too exact, the relationships are too complex, and the knowledge requirements are too advanced for ancient civilizations working independently with primitive tools and limited mathematical understanding. Consider the probability of accidentally incorporating pi into a building's proportions. Pi is an irrational number with infinite decimal places. The chances of stumbling upon its precise value through trial and error or aesthetic judgment are essentially zero. The same applies to the golden ratio, the speed of light coordinate relationship, and the Earth scale model proportions. Each relationship independently has negligible probability of occurring by chance. When you combine multiple impossible coincidences in a single structure, the probability becomes so vanishingly small that chance ceases to be a viable explanation. This level of sophistication can't be accidental. It creates what historians call the knowledge problem. How did ancient Egyptians acquire sophisticated understanding of mathematical and astronomical relationships that weren't formally discovered until thousands of years later? Conventional archaeology offers no satisfactory explanation for this paradox. One possibility is that ancient civilizations were far more mathematically sophisticated than mainstream history acknowledges. Perhaps mathematical knowledge developed much earlier than traditionally believed, then was subsequently lost during periods of social collapse or cultural disruption. This explanation requires us to revise our understanding of ancient intellectual capabilities, but it doesn't violate any fundamental historical principles. Another possibility is that advanced mathematical knowledge was inherited from an even earlier civilization that achieved sophisticated understanding of mathematics and astronomy before disappearing from the historical record. This explanation aligns with the dating anomalies we've encountered in previous chapters and could account for the sudden appearance of advanced knowledge without obvious developmental precedents. A third possibility is that ancient civilizations had access to information sources that mainstream archaeology doesn't recognize or acknowledge. This could include lost written records, oral traditions of extraordinary accuracy, or observational techniques that were more sophisticated than traditionally assumed. Regardless of the specific mechanism, it demonstrates that someone, at some point in the distant past, possessed knowledge that conventional chronology says shouldn't have existed. Mathematics doesn't lie. Numbers can't be explained away with creative theories or dismissed through academic authority. We've seen that coincidence is statistically impossible, and accident defies logical explanation. That leaves us with intentional design by builders. Embedded within these numerical patterns may be information about the pyramid's true purpose, information that has been deliberately hidden from view for thousands of years. The mathematical sophistication we've uncovered tonight is just the surface layer of a much deeper puzzle. Behind the pyramid's sealed doors and within its hidden chambers lie discoveries so significant that they've been systematically concealed from public knowledge. And those discoveries might finally reveal not just what the Great Pyramid really is, but who actually built it, and why they went to such extraordinary lengths to preserve their secrets in stone. Let's be generous for a moment and set aside all those pesky questions about dating, engineering, and hidden knowledge. We'll accept that this colossal monument really was built by Khufu as his eternal resting place, but then you step into the king's chamber, inside it, supposedly the grand burial room, and something immediately feels off. Silence. Emptiness, stone walls bare of any decoration, just a granite box sitting in the corner like a forgotten shipping container, with no lid, no inscriptions, and no evidence it ever contained anything more significant than ancient air. Compared to the richly adorned tombs of other pharaohs and nobles, the contrast is so stark that it's almost comical. We're supposed to believe that Khufu, allegedly the most powerful pharaoh of the mighty Fourth Dynasty, the man who commanded the resources to build the world's most impressive monument, chose to be buried with less ceremony than a middle-class merchant. It's a bit like discovering that Jeff Bezos chose to live in an empty shipping container while his assistant got a penthouse suite overlooking Central Park. Something here doesn't add up, and it's not a small discrepancy. It's a contradiction so fundamental that it should make anyone pause and ask the obvious question. Are we sure this was actually built as Khufu's tomb? To understand just how bizarre the Great Pyramid's emptiness really is, we need to take a step back and consider what ancient Egyptians actually did when they buried their pharaohs. And I mean, really consider it, because the contrast with what we find in the pyramid is so dramatic that it borders on the absurd. When Howard Carter first peered into Tutankhamun's burial chamber by candlelight in 1922, his famous first words were "wonderful things," not empty room or granite box or mysterious absence of everything you'd expect to find. The tomb was so packed with grave goods that it took Carter's team nearly a decade just to catalogue and remove everything. We're talking about 5,398 individual objects crammed into a relatively modest tomb: golden thrones, precious jewelry, ornate beds, ceremonial daggers, board games for entertainment in the afterlife, perfume bottles, and underwear. Yes, even pharaohs needed clean undergarments for eternity. Even relatively minor nobles got the full treatment. The tomb of Ramose, a vizier under Amenhotep III, contains elaborate paintings depicting the deceased's life, detailed lists of offerings, and extensive religious texts. The tomb of Seneb, a court dwarf, includes beautiful artwork and hieroglyphic texts celebrating his life. They were just civil servants, but they received more elaborate burial preparations than what we find in the supposed tomb of the mightiest pharaoh of the fourth dynasty, which makes the Great Pyramid's stark emptiness more puzzling. We get a room that looks more like an unfinished basement than the eternal resting place of a god-king. The king's chamber, as it was named, supposedly the most sacred space in the entire complex, contains exactly one object, a granite box with no lid, no inscriptions, and no decoration of any kind. The box itself is curious for several reasons, not least of which is that it's slightly too large to fit through the entrance passage, meaning it had to be installed during construction rather than brought in later with a royal burial. The walls surrounding this lonely granite box are completely bare. No hieroglyphs, no paintings, no decorative elements whatsoever. In a culture that covered every available surface with text and artwork, this absence isn't just unusual, it's unprecedented. It's as if someone built the most elaborate cathedral in history and then forgot to include any crosses, stained glass, or religious imagery. The Queen's Chamber, despite its name, shows no evidence of ever housing a queen or anyone else. Like the King's Chamber, its walls are devoid of any decoration or text. There's a curious niche in one wall that some have suggested might have held a statue, but if so, both statue and any evidence of its existence have vanished without a trace. The chamber's most notable feature is its connection to the mysterious shafts discovered by Dixon. The Grand Gallery, perhaps the most architecturally impressive space in the entire pyramid, is equally barren. This soaring corridor, with its precisely fitted granite walls and complex corbelled ceiling, contains no artwork, no inscriptions, no indication of its intended purpose. For a passage that leads to the pharaoh's eternal resting place, it's remarkably devoid of any religious or ceremonial elements. Most telling of all is what archaeologists haven't found despite more than a century of intensive exploration. There's no evidence that anyone was ever buried anywhere in the pyramid, not just no evidence of Khufu, no evidence of any burial at all. The entire structure appears to have been as empty on the day it was completed as it is today. The contrast becomes even more stark when we compare the Great Pyramid to other Fourth Dynasty tombs. Khufu's supposed mother, Queen Hetepheres, was buried with elaborate golden furniture, jewelry, and ceremonial objects that demonstrate the wealth and artistic sophistication of the period. Even mastaba tombs of high officials from the same era contain detailed reliefs, extensive hieroglyphic texts, and substantial grave goods. This creates what historians call the prestige paradox. The greater a pharaoh's earthly power and wealth, the more elaborate his burial preparations should have been. Khufu, as the builder of the world's most impressive monument, should have received the most elaborate burial in Egyptian history. Instead, he apparently chose minimalism so extreme it would make modern Scandinavian designers jealous. Orthodox explanations for this paradox tend to fall into several categories, none of which are particularly convincing. Some suggest that Khufu's burial goods were completely removed by tomb robbers, but no matter how thorough, they couldn't remove every trace of a burial. They might steal golden artifacts and precious stones, but they couldn't erase hieroglyphic texts carved into walls or eliminate all chemical traces of human remains. Others propose that the pyramid represents a shift toward spiritual rather than material burial practices, but this theory is contradicted by later pharaohs who returned to traditional, elaborate burials. Perhaps most creatively, some Egyptologists have suggested that the pyramid's very grandeur was considered sufficient burial preparation, eliminating the need for traditional grave goods and inscriptions. This is rather like arguing that someone who builds a magnificent house doesn't need furniture because the architecture itself is sufficient for comfortable living. Perhaps the most damning evidence against the pyramid as tomb theory is the complete absence of any mummy anywhere in the structure, ever. There are no human remains of any kind have been found in the Great Pyramid despite more than 2 centuries of intensive exploration. The entire point of elaborate tomb construction was to house and protect the mummified remains of the deceased, allowing their preserved body to serve as a vessel for the soul's return from the underworld. Without mummification, all the grave goods, religious texts, and architectural grandeur were meaningless. Even in cases where tombs were thoroughly ransacked by ancient thieves, fragments of mummified remains typically survive. Bandages, resin residues, organic traces, and bone fragments are remarkably persistent, leaving chemical and physical evidence of burial even when the mummy itself has been destroyed or removed. The Great Pyramid contains none of this evidence. Some Egyptologists have suggested that Khufu's mummy was removed by tomb robbers so thoroughly that no traces remained. But this explanation requires us to believe that ancient thieves were more efficient at evidence removal than modern forensic scientists are at evidence detection. Even complete destruction of a mummy would leave chemical traces that should be detectable with current analytical techniques. The absence of burial evidence becomes even more significant when we consider what the pyramid does contain: sophisticated engineering features that seem to serve no burial-related purpose whatsoever. The internal chamber system is far more complex than would be necessary for a simple tomb. The king's chamber and queen's chamber are connected by an intricate network of passages and shafts that serve no obvious burial function. The grand gallery, with its precise construction and acoustic properties, seems designed for purposes that have nothing to do with housing a dead pharaoh. Most intriguingly, the pyramid contains what engineers call relieving chambers, spaces above the king's chamber that appear designed to distribute structural loads and reduce pressure on the chamber below. While this makes perfect engineering sense, it's oddly sophisticated for a burial chamber that would only need to support the weight of a sarcophagus and some grave goods. It's the kind of over-engineering you'd expect if the chamber needed to house heavy machinery or withstand significant dynamic loads, not the kind of construction typical of burial spaces. The mysterious shafts that extend from both the king's and queen's chambers present another puzzle. While orthodox archaeology dismisses these as air shafts, their precise construction and alignment with specific stars suggest they may have served more sophisticated purposes. The southern shaft from the king's chamber points with remarkable accuracy toward Orion's belt, as it appeared in ancient times, while the northern shaft aligns with the ancient pole star. This astronomical precision seems excessive for simple ventilation. The chambers and passages inside create specific, resonant frequencies when sound is introduced, almost as if the structure was designed to amplify or manipulate audio in precise ways. While this could be coincidental, the frequency patterns are so specific that some researchers have suggested the pyramid might have functioned as a massive acoustic device. All of these features suggest a structure designed for function rather than burial. While we may not understand what that function was, the engineering details point toward active use rather than passive storage of a dead pharaoh. The Great Pyramid is classified as a tomb for exactly one reason: because orthodox archaeology requires it to be a tomb to support the narrative that Khufu built it as his burial place. The classification isn't based on evidence of burial, it's based on the need to maintain a predetermined conclusion about the monument's purpose and origin. The monument must be a tomb because Khufu built it, and Khufu must have built it because it's his tomb. Any evidence that contradicts this narrative is dismissed, explained away, or simply ignored. If the Great Pyramid wasn't built as a tomb, and if it's much older than mainstream archaeology admits, then we're left with an even more disturbing possibility. Whoever built this monument possessed engineering capabilities that shouldn't have existed anywhere on Earth for thousands of years. And that's where our journey into the impossible really begins. In 1993, when Rudolf Gantenbrink's robot discovered that mysterious copper-handled door inside the Great Pyramid, the world held its breath. Here was a chance to unlock secrets that had been sealed for millennia. But instead of celebration, Egyptian authorities shut down the project. Gantenbrink was banned from continuing his research, and the door remains unopened 30 years later. This wasn't an isolated incident. It's part of a pattern that repeats whenever discoveries threaten the comfortable narrative that ancient Egyptians built the pyramids with primitive tools and unlimited determination. Why would intelligent people fight so fiercely to protect a story that's crumbling under scientific scrutiny? For 30 years, Zahi Hawass was the face of Egyptian archaeology. His career, his reputation, and his international celebrity status were built entirely on defending the orthodox pyramid narrative. He wrote authoritative books, starred in countless documentaries, and established himself as the world's premier expert on ancient Egypt, all based on building a chronology. Imagine his impossible position when evidence started challenging those foundations. He had two choices: embrace new findings that would make his life's work obsolete, or find ways to explain away inconvenient discoveries. For someone who had invested 3 decades building expertise and authority, the choice was economically and psychologically inevitable. Hawass didn't just study Egyptian archaeology, he became Egyptian archaeology in the public mind. His passionate television presentations, his fierce protection of Egyptian heritage, and his dramatic defenses of pharaonic achievements made him a global brand. But that brand depends entirely on maintaining orthodox credibility. Consider what embracing alternative theories would have meant for his career. His books would become historical curiosities, his documentaries would need disclaimers, his reputation as the definitive pyramid authority would collapse. In his 70s, he would have faced starting over from scratch while admitting that his life's work was fundamentally flawed. But the pressure wasn't just personal. As head of Egypt's Supreme Council of Antiquities and later Minister of Antiquities, Hawass represented official Egyptian positions. Government officials didn't want to hear that their country's greatest achievements might not be Egyptian. University administrators couldn't afford their departments being associated with controversial theories. International colleagues pressured him to maintain established timelines that their own work depended on. Hawass became the enforcer for a system that couldn't afford to be wrong. Someone in his position couldn't embrace paradigm-shifting evidence even if the scientific merit was overwhelming. Modern Egypt's identity is inseparable from ancient achievements. "We built the pyramids" isn't just historical claim, it's the foundation of contemporary Egyptian pride and international recognition. The narrative provides dignity to a nation struggling with modern economic and political challenges. Egyptian children learn from early age that their ancestors accomplished the impossible. Political leaders invoke pyramid-building ancestors to inspire confidence in contemporary capabilities. Tourist materials emphasize continuity between ancient and modern Egypt. And the Orthodox story isn't history, it's essential national mythology. If evidence proves the pyramids predate Egyptian civilization, if analysis suggests unknown technologies, if astronomical alignments point to prehistoric construction, what happens to that identity? How does a nation psychologically survive losing its primary source of historical pride? The political implications are equally impossible. No Egyptian leader could survive acknowledging that the pyramids weren't Egyptian achievements. The admission would be seen as betraying national heritage and destroying the foundation of modern Egyptian self-respect. Tourism marketing would collapse overnight. International perception would shift from cradle of civilization to current occupant of someone else's achievements. The political cost would be enormous and immediate, while any benefits from historical accuracy would be abstract and long-term. Government officials understand this calculation perfectly. Supporting research that might undermine Egyptian achievement claims isn't just academically dangerous, it's political suicide. The system naturally selects for leaders who either genuinely believe orthodox narratives or are willing to defend them regardless of evidence. The Great Pyramid mystery persists not because evidence is lacking, but because solving it threatens too many people's fundamental interests. When comfortable lies generate billions in revenue and uncomfortable truths threaten millions of livelihoods, the choice becomes obvious to those in power. It isn't just the Egyptian authorities or their archaeologists. Most of the global academic establishment stands firmly behind the idea that the Great Pyramid was built by the ancient Egyptians. To this day, despite all the unresolved questions surrounding the monument suggesting that it might predate known history, is still treated as laughable. But let's be honest, academic institutions have a long track record of bending over backwards to protect established narratives, even when the evidence doesn't quite cooperate. After all, defending the story is often easier than rewriting the textbooks. In 1871, Heinrich Schliemann stood before the ruins of ancient Troy, vindicated after years of academic ridicule. Established archaeologists had dismissed him as a naive amateur chasing myths. Homer wrote fiction, they declared. No serious scholar wastes time searching for imaginary cities. Until Schliemann's spade proved them spectacularly wrong. The discovery should have prompted soul-searching about institutional blindness. Instead, academia quietly absorbed the new reality while maintaining the same attitudes that created the error. The pattern of resistance to paradigm-shifting evidence continued unchanged, ready to repeat with the next inconvenient discovery. When Klaus Schmidt announced the Göbekli Tepe discovery, a sophisticated stone architecture dating to 11,500 years ago, the archaeological establishment resisted fiercely. Such early complex construction challenged assumptions about civilization development that underpinned entire academic careers. Rather than embracing evidence for remarkable prehistoric capabilities, institutions found ways to dismiss, minimize, or explain away inconvenient findings. Initial response focused on dating disputes and alternative interpretations, preserving conventional timelines. Only when evidence became absolutely undeniable did mainstream archaeology grudgingly accept that humans achieved architectural sophistication millennia earlier than assumed. Even then, broader implications for ancient human potential were largely ignored. This very pattern explains the strangely muted response to the dating of the Dixon relics. Instead of welcoming what could have been breakthrough evidence about the origins of the pyramid, the archaeological establishment has been quick to downplay its significance. Perhaps, they suggest, the wood was already old when it was used, or maybe the dating process was contaminated. Yet somehow, when samples conveniently align with Khufu's supposed timeline, those results are embraced without hesitation. The pyramid evidence doesn't face resistance because it's weak or methodologically flawed. It faces resistance because accepting it would require admitting that fundamental assumptions about ancient capabilities, Egyptian chronology, and human development have been wrong for generations. That's the kind of admission that academic institutions are psychologically and professionally designed to avoid, regardless of what evidence demands. The pyramid case may be just the most extreme example of a pattern that stretches back through history, where institutional resistance helps preserve false claims of achievement that more honest investigation might have corrected long ago. When you stack up all the evidence we've explored, it points toward the same uncomfortable conclusion. The ancient Egyptians might not build the Great Pyramid, they could inherit it, but if not the Egyptians, then who and when? The first possibility sounds like fiction until you examine the details. Plato's account of Atlantis describes a civilization destroyed around 11,600 years ago, exactly matching the Younger Dryas cataclysm that ended the Ice Age and triggered catastrophic climate changes worldwide. Consider the technological parallels. Plato wrote about Atlanteans who understood complex mathematical relationships, tracked celestial movements with precision, and could transport enormous stones across vast distances. The second theory initially sounds even more fantastical, until you realize that every culture on Earth preserves stories about the same phenomenon. Biblical accounts describe the Nephilim, beings of extraordinary size and strength who built mighty structures in ancient times. Greek legends tell of titans who moved mountains and constructed impossible monuments. Hindu texts speak of the Danavas, giants with advanced knowledge who created architectural marvels. Egyptian records mention the Shemsu Hor, divine beings of great stature who ruled before the pharaohs and left behind monuments that later dynasties could never match. These weren't mythological creatures. They were consistently described as a distinct human population with exceptional physical capabilities and advanced intellectual abilities. The engineering challenges that make pyramid construction seem impossible for ordinary humans disappear when you consider builders physically capable of handling massive weights. The pyramid represents their final monument, a demonstration of capabilities that humans once possessed but gradually lost. The third possibility requires us to confront an uncomfortable truth about human history. We know almost nothing about what our species accomplished during the vast majority of its existence. Modern humans have walked the earth for 200,000 years, but orthodox history only attempts to account for the last 6,000. That leaves 194,000 years of potential human development completely unexplored and largely ignored by mainstream archaeology. The Ice Age provided remarkably stable conditions for over 100,000 years, more than enough time for sophisticated civilizations to rise, flourish, achieve remarkable things and be completely forgotten when climate catastrophe destroyed their achievements and scattered their populations. The location choice makes perfect sense for a civilization that developed during the Green Sahara period. When the region was lush and fertile, supporting massive lakes like Megachad that covered areas larger than the Caspian Sea, it could have sustained large populations with the resources and stability needed for extraordinary construction projects. Rivers provided transportation for massive materials. Forests supplied timber for scaffolding and tools. Abundant food sources freed large numbers of people for non-agricultural pursuits. When climate change transformed the Sahara into desert around 6000 BC, this advanced civilization faced catastrophic disruption. Populations that had flourished for millennia suddenly found their homeland becoming uninhabitable. Most migrated to the Nile Valley, bringing fragments of their sophisticated knowledge with them. This explains why Egyptian achievements often seem inexplicably advanced compared to their supposed technological development timeline. They were working with inherited knowledge from a much more sophisticated predecessor civilization. The Egyptians didn't fully understand what they had inherited. They could observe the mathematical relationships in the pyramid's design, but they couldn't replicate the precision of its construction. They could use the astronomical alignments for ceremonial purposes, but they lacked the broader cosmic understanding that had originally motivated such features. They preserved fragments of advanced knowledge while gradually losing the context that made such knowledge possible. Regardless of which specific theory proves correct, whether Atlantis survivors, giant builders, or an advanced Ice Age civilization, all point toward the same fundamental realization. The Great Pyramid was built by humans far more sophisticated than orthodox history acknowledges. The builders, whoever they were, achieved something extraordinary. Their greatest accomplishment wasn't constructing an impossible monument. It was encoding information that would eventually inspire future civilizations to question their assumptions about what human beings can achieve. We began this journey with a simple question. Why do so many people find it hard to believe that Bronze Age Egyptians built the Great Pyramid using primitive tools and unlimited determination? After exploring all of the evidence, the answer has become unavoidably clear. They reject the orthodox story because the orthodox story deserves to be rejected. The dating relies on Victorian-era graffiti and circular reasoning that would embarrass a philosophy student. The tomb theory points to burial chambers that contain everything except evidence of burial. The engineering explanations require us to believe that ancient workers accomplished feats that defeat modern machinery. The mathematical relationships demand that Bronze Age farmers accidentally discovered constants that took modern civilization millennia to calculate. And when researchers find physical evidence contradicting these comfortable assumptions, access gets denied and discoveries get buried in bureaucratic silence. With each passing year, the evidence kept piling up. In 2023, advanced muon tomography confirmed the existence of a mysterious 9-meter corridor hidden behind the pyramid's north face, the first new internal discovery in over a century. The massive Big Void above the Grand Gallery, initially discovered in 2017, has now been confirmed at over 40 meters in length by multiple independent teams. By 2024, ground-penetrating radar revealed L-shaped anomalies buried in the Western Cemetery near the pyramid complex. Artificial structures 33 feet long and 6.5 feet deep, suggesting unknown constructions waiting to be excavated. The discoveries accelerated into 2025 when Professor Corrado Malanga from the University of Pisa, using synthetic aperture radar, claimed to have detected something extraordinary: vast underground networks beneath the Giza pyramid, including 8 vertical cylinder structures extending over 2,000 feet into the earth. Each discovery should have sparked celebration and intensive investigation. Instead, the pattern remains depressingly familiar: brief announcements followed by access restrictions, limited exploration, and official explanations that raise more questions than they answer. When Italian researchers claimed to have detected vast underground networks beneath the Khafra pyramid using synthetic aperture radar, Zahi Hawass immediately dismissed their findings as fake news, not through scientific refutation, but through institutional authority. Most people reject the orthodox pyramid story because they recognize, perhaps unconsciously, that it doesn't adequately explain what they're looking at. When you stand before the Great Pyramid and truly contemplate its precision, its scale, its mathematical sophistication, and its purposeful design, something inside you knows that the conventional explanation falls short of the reality. And that's the real reason skepticism persists. When official voices shut down inquiry rather than embrace it, people are left to trust their own eyes, and their eyes tell them a very different story. The Great Pyramid has waited patiently for over 4 millennia for us to develop the courage and capability to decode its message. Perhaps it's time we stopped protecting our limitations and started celebrating human potential. Perhaps it's time we admitted that the most extraordinary monument on Earth might actually have been built by extraordinary people whose achievements we're only beginning to understand. The ancient voices echo across time, speaking through precision and permanence, reminding us that human potential has no limits except the ones we choose to accept. The only question remaining is whether we'll listen